Okay, so let's use our combination formula in a normal everyday problem, which I don't think you're gonna do this next time you go to a restaurant, but it would be kind of fun to try, honestly. So this is example 2. Example 2 says you order a sandwich at a restaurant. You can choose 2 side dishes. So you can choose 2 side dishes, right, from a list of 8. And how often does that happen, right? Where you take, like, if you've ever gone to the Tennessee, right, Tennessee barbecue, right, they ask you to choose 2 sides, and they're like 8 or 10 sides, right? So you're choosing 2 side dishes from a list of 8. Okay. How many combinations of side dishes? Have you ever wondered how many combinations? We're gonna find out. All right, so we're gonna use our formula. C n r equals n factorial, n minus r factorial times r factorial. So C, I'll do it here so I have more space. I'm choosing from a list of, I have 8 objects, right? 8 side dishes, and I'm choosing 2 at a time, 2 side dishes. So I have 8 factorial divided by n minus r. Well, that's 8 minus 2 factorial, and then 2 factorial, because r is 2. So how does that work out? I have 8 factorial. Before I reduce, I'm just going to keep it as a factorial just to see if I can reduce my work. And on the bottom, I get 6 factorial and 2 factorial. So up here, let me get 8 factorial is 8 times 7 times 6, 5, 4, 3, 2, 1. So I'm just going to make that 6 factorial. And on the bottom, I have 6 factorial and 2 factorial. I see that I can cancel something. I can cancel the 2 6 factorials. And I can see that I end up with 8 times 7, right? Which is 56. And 2 factorial is just 2 times 1 on the bottom, right? So my total is 28 possible combinations of side dishes, okay? So that's example 2. Second example, actually, is something I have worried about frequently, because I was on the yearbook committee years ago in high school. And so that's example 3. So the yearbook editor has selected 14 pictures. So you have 14 photos, including one of you and your friend. One of you and your friend among those 14 photos. To use in a collage for the yearbook. The photos are placed at random. There's room for 2 photos at the top of the page. So there's 2 photos at the top of the page. What is the probability that your photo and your friend's photo are the 2 placed at the top of the page? Okay, so there's 14 photos, and one, including one of you and your friend. So these are 2 photos, right? And you'd really love it if your 2 photos, you and your friend, are at the top of the page, right? Who wouldn't? What is the probability that your photo and your friend photos are both placed at the top? All right, well, this is a combination because it doesn't matter what order they're in as long as they're at the top. You just want them selected, right? 2 at a time at the top. So this is a combinations issue. And so you have 14 photos taken, and you want to take 2 at a time, right? And so you're going to find out how many possible combinations you can get of these 14 photos taken 2 at a time, okay? Because you could be any of those 14 that's at the top of the page. You want to find out how many ways that can happen. So we have 14 factorial over 14 minus 2 factorial times 2 factorial. 14 factorial times 12 factorial times 2 factorial. Or you have 14 times 13 times 12 factorial. And we're going to stay there because here, why bother going 12, 11, 10, 9, 8 if you can cancel right away with 12 factorial here and 2 factorial. So we now do what we did above. We can cancel this and this, and you end up with 14 times 13 divided by 2 times 1. And when you calculate that, you end up with 91. So there's 91 ways of getting 2 pictures, right, at the top of the page. There are two that are selected at the top of the page. But that's not what they asked. They asked, what's the probability that those particular 2 pictures are you and your friend's photo? And that probability of that favorable outcome, if you remember, P is favorable outcome. There's one favorable outcome. You want these 2 pictures to be at the top over total outcomes, right? So that's one favorable outcome out of 91 possible outcomes. Okay, and so works out to, I don't know, a little bit less than 2%, right? It's close to between 1 and 2% chance of getting that to work out. Okay, well that is the end of 13.3, and tomorrow we will do our very last lesson, 13.4.